Hi everyone, my name is Surbhi Paul. Welcome to this webinar. Today's topic is deploying elastic self-service load balancing for VMware NSX. And we have been doing these webinars on a recurring basis every month, and we run these in different time zones. So thanks a lot for attending in whatever time zone you are in. Well, some of just very few housekeeping guidelines before I hand it over to Bhushan, who will be presenting or going over this webinar and demo with you. Um, the format of this is it's about 60 minutes long, and the first part will be a presentation that Bhushan will be doing, and then he will be showing you a live demo. And we can keep it interactive with question and answers. If you have any questions, please put them in the questions tab, and we can help address those questions as the webinar is going on. And so those of you who have already registered, that's great. You will get to see or hear the presentation and as well as the demo. And for your co-workers who have not been able to join this, maybe you can share the recording as well as the slides, which we will be sending you as a follow-up email. And maybe if they're not able to make it this time, then they can register for the next one. As I mentioned, we have this every month. And again, you can use a Q&A window to ask questions. So we'll try to keep it interactive because it's more fun that way. So without further ado, Bhushan is the speaker for today's webinar. Bhushan, do you want to take it away with the presentation first?
Sure. Thanks, Surabhi. Hi, everybody. So my name is Bhushan Pai. I'm a Senior Technical Product Manager with the Networking and Security Business Unit at VMware. We'll be talking today about deploying Elastic Self-Service Load Balancer for VMware NSX. So the product is called NSX Advanced Load Balancer, which was formerly known as AVI Networks. So if I may call it either way, I can call it, if I call it AVI, I'm talking about the same product in the slides. All right. Yeah, so today's agenda is we'll spend around 25 to 30 minutes going through the introduction, the challenges that our customers face, the enterprises face in for deploying load balancing today, how our integration works with NSX, and then we'll do a quick dive into the technical details and see a live demo. And then we'll conclude with some takeaways of how to engage and how to test drive this AVI product. So let's start with the introduction to NSX and NSX Data Center. Over the past decades, there have been many innovations in the data center technology. Virtualization has made it easier to provision, manage, and scale compute and storage resources on demand. But one of these areas, but this advancement is lacking in one of the areas, which is networking and security. Virtualization in networking and security is necessary to allow your IT to keep up with the changing business demands and to better secure your application and data centers using distributed security policy while keeping the operational cost low. Traditionally, the hardware-based networking security solutions are very complex to design and deploy, and they are usually very expensive and also are partially automated. VMware NSX takes a software-centric approach to solve these problems by implementing network functions including switching, routing, firewalling, IDS, IPS, and load balancer in a distributed architecture. And this is not just limited to VM workloads. NSX also provides and extends these network functions to individual containers running inside these VMs. The simplified design tailors the network to meet application needs, connecting and protecting your workloads wherever they are deployed. Out of these network functions, today we are going to focus more on the VMware NSX Advanced Load Balancer. as you see, NSX integration is just one part of our supported platforms. NSX AVI is actually a truly multi-cloud load balancer, and we have a lot of customers, enterprise customers, deploying AVI in different cloud platforms. Usually, let's take a look at what the load balancing challenges enterprises face in load balancing environments, and how AVI provides a solution for these problems. So usually, legacy load balancers are usually deployed as active standby pads. Even then, they have to be over-provisioned. They are rarely ever completely utilized. This is because the IT department has to think ahead for future growth and expansion. Again, if a large data center or a large organization might have tens or hundreds of these load balancers within their data center. These becomes siloed capacity of load balancing that your bits needs to be managed over. The placement of the bits is manual. The network connections for each of these appliances are manual. So all of this increases the complexity. On top of that, each one of them has their own dashboard or their own management console. So managing each and every one of these separately becomes really difficult. It's really hard to automate also. So just imagine when it comes to upgrade, the network admin or the load balancer admin has to go and upgrade each and every one of this individually. Most of these legacy appliances don't have a really good observability also. So it's a kind of a black box. So when it comes to debugging any of your load balancing or network problems, the only solution that usually is looked at is TCP dump kind of a thing, and which leads to a lot of finger pointing between the network and the app owner teams. And it's really difficult to debug your applications that way. And these legacy solutions are not properly designed for public cloud and multi-cloud environments. Usually, the public cloud support is an afterthought in these solutions. The solution to all of these problems is actually separating the control plane and the data plane. All of these appliances usually have the control plane and the data plane on the same, which leads to all of these complexities. If you separate the control plane and the data plane, you get a centralized location for controlling and managing everything, while you have a distributed load balancing fabric to manage the actual traffic. This is what AVI does. So let's go over the AVI architecture a bit. AVI has a modern distributed architecture. There is a centralized AVI controller, which is the brains of the product. And then there is the actual data load balancing traffic is handled by the service engines sitting in the data plane. Since this is a software, it can be deployed anywhere, right from a bare metal x86 box or as a VM in VMware environment, or even as for containers or in public cloud. Because of the controller, you get a centralized location, a single pane for the application and the load balancer admin to manage the whole load balancing fabric. Since this is software, the controller can elastically scale out and scale in the service engines whenever required, as the traffic changes or whenever the administrator wants to. It's completely resilient due to inbuilt automation and intelligence. If any of the service engine fails, the controller is capable of creating a new one and keeping your traffic healthy. There is a lot of built-in automation, which we'll also see in a demo. But the AVI controller ties into your infrastructure and automates a lot of things, and also provides basically everything you want to configure on the AVI controller can be done through REST APIs, and we have a lot of automation suites supporting that, like Ansible, Terraform, Python SDKs, Go SDKs, etc. As the traffic flows through the service engines, they collect hundreds of different metrics and analytics points, which gets bubbled up to the controller, and the controller has a rich dashboard which shows you all the analytics for your for your application at per virtual service basis. Specifically to NSXT integration, like I said, AVI controller ties into the underlying infrastructure. So even up here, AVI automates the life cycle of the service engine. It automatically detects all the all the logical switches, and connects the service engines to correct logical switches wherever load balancing is required. It the pool used for load balancing can be entered as a NS group, so that as your application scales or changes, the the load balancing pool also dynamically changes with it. Because of the way RHA works, which we'll again see in the technical details, it gives a better performance as compared to any other load balancer in the NSXT environment. Because of a dashboard, it becomes really easy to debug your application traffic and also see how your application is performing with respect to metrics. And the metrics that you get on the dashboard are not just used by the admin to debug the applications. They are also internally used by the controller to make intelligent decisions to scale out or scale in. For example, if you have a large number of you suddenly get a large number of requests, your AVI controller can automatically scale out your service engines to support those extra requests. So just a note before we go ahead, AVI NSX Advanced Load Balancer is the go-to strategy for is the main strategy for VMware going forward for load balancing in NSX environment. We have a rich roadmap for integrating with NSX. Basically, right now we integrate with the NSX NSXT manager, and in the future users will also be able to directly configure the load balancing through NSX UI itself. The recommendation for our customers is that if you are starting to use NSXT and need load balancing, to get started with AVI, as well as for brownfield customers who are already on NSXV and are migrating to NSXT, even they should start using AVI right away. All right, so let's move on to some integration details. The way AVI controller is deployed is something like this. So both AVI controller and the service engine are deployed as VMs in the NSXT and vCenter environment. The AVI controller is deployed adjacent to the NSXT manager and vCenter in the management workload section. So wherever your management workloads are deployed. The service engines are automatically deployed by the AVI controller. The user does not have to go and deploy it manually. And it becomes a part of your NSXT network and security fabric. The service engines get deployed in the workload side of their infrastructure, where your actual application VMs are running. The controller automates everything from the lifecycle, the network connections for the service engines. It manages your application IPAM and DNS, automatically manages scale out of your load balancing, and also provides NS groups for all the objects that AVI creates, so that your NSXT security admin can manage your security for your application using those. Just showing the scale out of here. So let's go through the day 0 and day 1 configuration steps. So the configuration looks like something like this. Once you deploy the AVI controller requires configuration of a cloud. A cloud is nothing but a way for the AVI controller to tie in with your infrastructure. So on day 0, the admin goes and configures the cloud. He provides the NSXT manager credentials and the vCenter credentials to AVI controller. And from that point onwards, AVI controller syncs all the inventory and the infrastructure objects from NSX Manager, like it figures out all the transport nodes, all the transport zones, the tier 1 gateways, logical switches, etc. And from the vCenter side, it gets all the ESXi hosts, the clusters and data stores, and it also publishes the service engine OVA to the content library on the vCenter. Then whenever application admin creates a new virtual service, there are a few things that happens. So the creation of the virtual service triggers the placement logic on the controller. It tries to see if there is a service engine already present. If it's present, it will place the whip. But since this might be the first time a virtual service is created, there is no service engine present in the beginning. So the thing it will do is it will run an API to vCenter to get the service engine deployed. vCenter will automatically deploy the service engine from the image in the content library. It will vController will then run API to NSX Manager to manage all the WIP routing and create NS groups and services to allow the network admin to manage the security for this application. The way this works is the way the virtual service placement works is something like this. So initially, if you need your virtual service to be able to be accessed from an external network, the NSXT admin needs to configure the tier one gateway to redistribute the WIPs that we create, and the T0 again advertises those WIPs to the outside world using BGP. Now, when a virtual service is created, the corresponding WIP is placed on one or more service engines. For example, in this case, we are running active-active. Just as an example, we do have other HA methods like active standby and plus and buffer. Once this is placed, it also publishes the WIP to NSXT Manager using APIs, and NSXT Manager configures those WIP static routes on tier 1. This way, whenever a external client makes a request for your application, it gets routed over the external network to the tier 0, and the tier 0 forwards it to the tier 1, and tier 1 has the WIP route which sends it to the correct SE. In case of scale out, similar things happen again. vController places the WIP on multiple service engines and updates the static routes to have multiple next hops. Now, since the tier 1 has multiple next hops, it automatically does ECMP across these service engines, and that's how the external client traffic reaches the load balancing WIP. Let's take a look at some benefits of this kind of architecture and how we provide better load balancing on NSXT. The most important part of this is that vController gives a centralized management console for all the load balancing requirements. The user does not have to go and manage each and every load balancing individually. It's all policy based. You just configure what you want on the virtual service side, and all the infrastructure needs are automatically satisfied. And it can run for both VM as well as a continuous environment. The vController has intelligence to automatically manage the WIPs. So if any service engine goes down, it will automatically migrate the WIPs, create a new service engine, and any new WIP created can be placed on it again. There is management plane separation using tenancy as well as data plane separation using service engine groups. So there is proper isolation and security built into the product. With respect to scale, Avi allows users to scale up the SEs as well as scale out the SEs. That is, both horizontal and vertical scaling is supported. So just a single core of the service engine can handle 2,500 SSL TPS, and users can scale this vertically to larger servers and have greater performance that way, or they can keep the SE footprint low but scale out or scale horizontally to multiple service engines and gain more performance that way. When it comes to upgrades, we have really flexible granular upgrades support available. So say you have multiple tenants in environments like in a VCD-like environment where you have multiple organizations uh, managed by NSXT. From a controller, you can select which one of them you want to upgrade and selectively upgrade only those. So you can manage the downtime on your for your upgrades across your tenancy very easily.
So Bhushan, there's a question by Ravindra. He's asking if the virtual service can it be created on the NSXT manager, or is the primary interface to Avi the controller?
Yeah.
Can you
So yeah, thanks, Sirpi. So currently the main management portal is Avi Controller, and we'll see that in the demo today. But we are working on integrating the portal directly into an NSXT Manager also. So your users will be able to directly create all the load banks, create and manage all the load balancing through NSXT Manager. And that's on our roadmap for 2021. All right. So yeah, just last point on the benefit side, which we'll again see in the demo, but just an overview out here. So service engine gathers metrics and analytics and bubbles it up to the controller, which we can show, very pretty dashboard for the users to log in and debug their applications. There are multiple things like end-to-end timing, where you can see which component in your load balancing path is actually causing the latency issues. There we can see logs for each and every transaction coming in and out of your application. So easy to debug your DDoS attacks or any performance-related issues. All right. So, Sylvie, do we have any other questions before we go to the live demo?
We don't at this moment, so I think we can get into the demo, and as the questions come by, we can stop and answer them. We can pause and answer them.
Okay, sure. So let's move to the demo now. So for the demo, what I have is the Avi controller UI that you are looking at right now. I also have a NSXT manager running out here, and of which is managing the networking and security over the vCenter that you see. The topology for the demo is something like this. So we have a couple of T1s with applications, one of them having applications running on them, and we have a Avi specific T1 and segment running for Avi service engines to connect for the management interface. And just like we saw in the PPT right now, the service engine connects to both the management for management traffic and the data segment for managing the webs on it. On the Avi controller side, the day zero operation that we talked about, configuring the cloud, is what you see out here. Currently, we have configured NSXT cloud, but like I said, Avi is a completely multi-cloud load balancer. So we do support various other clouds out of the box, like AWS, Azure, etc. Also, let's take a look at what we have configured in the NSXT cloud. So we configured the NSXT manager credentials, using which it automatically discovers all the transport zones that are there in your NSXT, and we configure the transport zone over which we want to have the load balancing done. We select the management segment, and we also select the tier 1 and the segment over which the applications are deployed. We add the vCenter from which we automatically pull from the compute managers that are configured on the NSXT side. So if you have multiple vCenters, you can add more of these out here too. AVI controller also has its own inbuilt IPAM and DNS. We have configured an IPAM out here right now. But yeah. And we can also manage the FQDN for your applications. Yeah. So with the day zero configuration, then the next step is to configure the virtual service itself. I already have one, but let's go ahead and see it in action by creating a new one. So we'll go for the advanced setup to see the steps in detail. The first step is to select which cloud you want to create the virtual service on. So right now we have only NSXT cloud, but we can the same controller can manage load balancing across multiple clouds. So it can be across multiple NSXTs or on-prem as well as public cloud or anything like that. So yeah, let's get started with it. So let's create a virtual service named VS Test. You don't have to put in any VIP IP. It will auto-allocate it from the IPAM that we just saw. You just need to select which segment you want to place the VIP on. Select the tier 1 router. So that's the tier 1A that we saw out here. And you can create or select the type of service, virtual service you want to create. So let's create a secure HTTP service and make it listen on port 443 on SSL. As soon as you click SSL, it automatically gives you the SSL profile, gets applied, the SSL certificate gets applied. Right now, let's just use the default certificate, but if you want, you can import your own SSL certificate and apply to it. For the pool, we can, one of the main integrations out here is that on the pool side, you can add your servers as a network, as a NSX, NSG basically, as an NS group. So if you go to inventory and groups on NSXT side, when you deploy an application, you can automatically, you can create a dynamic NS group, and you can add your application servers into it, either dynamically or statically. And as you change your NS group membership, the pool membership also changes with that. So once that is configured, there are many other configurations out here. We'll not go through all of them, but the main ones are you can configure network security, HTTP security, or HTTP request and response policies to do content switching based on any host header or cookie or many other things, many other layers and parameters like that. You can enable analytics, so you can collect the metrics in real time if you want. You can log all the headers of the packets coming in and out. You can manage the traffic logs from here. And that's some advanced configurations that we'll just leave default for now. And just like that, your application, the virtual service is up and running. So the only thing it's doing is it's connecting one of the virtual services, one of the service engines to the correct logical segment. So like I said, once the virtual service is created, the controller sees if it already has any service engines running. Since it had already 2 service engines running, it selected one of them and is trying to connect the interface of that to the correct logical segment or NSX. So let's give it a few more seconds and it will be done, as you see. And just like with that, your virtual service should be up and running. Along with, let's see, in a different way. So you have your virtual service managing a pool, of two servers, which it automatically picks from the NS group and is placed on one of the service engines. Along with that, we also configure its other NS groups by itself. So it will configure NS groups for the controller cluster IPs, the service engine IPs, and specifically for the virtual service service engine members and all. So your application admin can use this in a distributed firewall to secure our application. For example, out here, I have configured the client to SE traffic. Basically, you can manage which client can reach the WIP IP and using what kind of service to this application. Basically, securing your securing your application access that way. Yeah. Scaling out in an NSXT environment is also simple. By default, as the traffic flows and if you have configured the auto scale configurations, on the service engines can scale out automatically depending upon the CPU utilization of the SE or the throughput or PPS, etc. But just for the demo, let's scale it out manually right now. So as you saw, it was placed on just a single SE, and with just one click, now it's placed on two SEs. For a better visual, let's move on to this. So right now, this virtual service automatically gets placed on two service engines. And all of this is automatic. And if you want to scale out even more, we will automatically create a new one. So since we had only two service engines and we want to scale out to a third one, we noticed that it needs to create a new one. And you see on the vCenter side, it's actually deploying a new OVF template to create a new service engine. And once the service engine will come up, it will connect back to the controller, and your application will be scaled out 3 ways, running active, active, active. Yeah. Talking about that, let me show you the various HA methods that we have. So on a given service engine, the service engines can be grouped together using a service engine group. Basically, the service engine group tells you what is the characteristics that you want for your application. You can set the high availability to active standby, active active, or N plus M buffer. N plus M buffer is similar to active active. It's just what it means is there are N service engines which are running active active, and there are N service engines which are buffer. Buffer service engines are required in case when some active service engine goes down or crashes, the WIP can automatically be migrated to an existing buffer service engine so that your total scale remains constant. You can manage many other things like the footprint of your service engine, how big, how many cores, and how many CPUs and memory you want on the service engine. You can scale you can manage the scale you want, maximum scale you want the service engine to go to scale out to, etc. All right. So this environment has just recently created virtual services. So let me open up a new demo environment to show you more on the feature side. So as you see, this demo environment has much more things configured. It's truly configured for multi-cloud environment. So we have the same controller managing load balancing across AWS, Azure, and on-prem on vCenter also, and also across multiple data centers. So we are currently just looking at the San Francisco data center in a demo lab. For sharing the same infrastructure across multiple teams, you can divide this up into multiple tenants, as you see out here. Let's go to the demo tenant and take a look at the applications. We have that. Just like we configured the virtual service on NSX side, you see we have many applications out here. And let's take a look at one of these applications called Ravi Demo. So this virtual service has multiple pools in the backend over which we have configured content switching policies. So suppose based on path. So anything going for your application slash downloads will be sent to the downloads pool and will be load balanced to one of the backend servers. Anything going for contactors will go to this pool and will be load balanced to the corresponding server on the backend. The dashboard gives you a bird's eye view of how your application is working. Basically, what service engines your application is placed on. If there is something wrong on the backend pool members, why it is wrong. Just if you hover over the health of that application of that server, you'll see that it's marked down because of the health monitor is failing on that. And each and every object you see out here has its own health score. So the pool will have its own health score based on the performance, resource penalty, and anomaly penalty, etc. So right now we have one service down. That's why we have the total health of this pool is a bit low. Similarly, even the virtual service will have its own health score based on the performance that it sees of the traffic that's flowing through the virtual service. Resource penalty, again, there is anomaly penalty, and also security penalty. Security penalty actually gives you a feel of how secure your application is. If you are using self-signed certificates, or if your certificates are valid but they are about to expire, we'll automatically add a security penalty so that you take notice and remediate it. If you open up this virtual service on the main screen, you see a lot of information about your how your application is performing. You see end-to-end timing in a granular fashion. Basically, you can see what the client RTT is, what the server RTT is, how the application response time is changing over time, how fast is the data being transferred, etc. And we also get a summary view up here of over the last whatever time window you select. So we are looking at the past 6 hours. So this is a summary view of how your application latencies look like. Yeah, there are other metrics like throughput, open connections, connection per second, requests, etc. And you get these kind of metrics for each and every application running in your environment. And these things help you debug your application really easily. For example, you see between 7 a.m. and 8 a.m. today, we saw a uptick in the latency, overall latency that your clients were facing. Usually, if this gets flagged, the blame goes to the network team saying that the network is slow. But just look at the metrics UI out here shows that the yellow part, which is the app response time, is what changed. The client RTT and the server RTT actually remained almost constant. The server RTT is actually almost negligible. The major part of this is taken up by the app response. So maybe it's something on the server side which is slowing down. The servers are slow, not the network. So getting to the root cause becomes really simple with this kind of analytics and metrics dashboard. We also have logs, provide logs for each and every transaction in your application, and we classify them into non-significant and significant logs. Significant logs are the ones which end up in error, like 400s, 500s, redirects, or even 200s, which take really long time to get processed. Basically, anything that doesn't meet your SLA. And you can define your SLA in the analytics profile. For example, if you take a look at one of these 200 errors, 200 but taking a really long time, you can see where the traffic is coming in from, which load balancer actually handled the traffic on which and which backend pool member was it load balanced to. You can even see in detail each and every header field in the request and the response side. All of these help you debug your applications also. For example, let's take the latencies out here. Yeah. So total latency out here is this one. Just a moment. Okay, yeah. So on the right-hand side, you'll see kind of a histogram of all the logs that you see that you are seeing on this page. So if you want to filter out everything that has a really high latency, you can just click on those things or just type it out in the search bar up top out here, and you'll see that most of these are in the same range that we saw in the main analytics screen. Between 7 a.m. and 8 a.m. Is when the latency shot up, and we already know the reason for it, which is the application was slow. Another thing to debug will be if your application is throwing many 404s. You can simply select that. So you can shift on based on the response codes and click on all the 404s. That will list all the 404s that you have in your application traffic. And then you see that most of them are for this logo.png file. That maybe this logo.png file is missing on some of your backend servers. So to do that, you can actually see which server IPs was this load balanced to. And it will gather all the data, and it will show you exactly which server is all of these are being load balanced to. And you see that this logo.png is actually missing on just one of the servers, because of which you are getting 404s. So debugging your application also becomes really simple with this. We also have a security screen where it shows you the distribution of all the different certificate types your clients are using, what TLS version your clients are using, what certificate RSA or EC your clients are using. And if you have DDoS attack happening on your virtual service, even those get logged out here. So as a part of the advanced load balancer, there are hundreds of different other features that we support, like GSLB and web application firewalls, and we do have other webinars for that. So I won't be going over all of those details right now. So that's all I had on the demo side. If you really like this product, there are many ways you can engage with us. You can start with webinars like these. Share out the recordings of these webinars to your colleagues. If you want to go ahead and try it out yourself, there are also many ways for that. So which are there? You can go ahead and try out a hands-on lab on my VMware if you have a VMware ID, or you can also register for one. Similarly, you can also try it out on a test drive that we have. Let me open this up too. Right. Yep.
Bhushan, we
So,
have we have couple of questions. Can you talk a bit about the HA options for the high availability for control plane components? Does the control plane, the question is, has a master which holds the whip, and in case of the master failure, the whip is claimed by the next elected master?
yes, yeah. So kind of what you said. So let me actually show you how it is. Yeah, on the controller side, we can actually have for a production environment, we actually support a cluster of 3. So you can add 3 of them, and there is a cumulative controller cluster IP, which is a whip, floating whip, which is taken up by the leader of the cluster. And whenever a controller goes down, if it's the leader, the whip automatically gets assigned to the next available follower. All the 3 controllers actually shard the role of shard the control plane. So whatever you configure on one controller is automatically synced across all of them. If you guys have any other questions, free to answer right now.
Yeah, and do we have integration with vCloud Director? Like, what are the possibilities and what integrations are there?
Yes, so we actually do support VCD. Actually, it's the other way around. vCloud Director actually supports AVI starting from the 10.2 release. It has built-in dashboard to directly manage everything on AVI from the VCD portal itself. There are ways, apart from the day zero configuration, the virtual service creation and all can be automatically managed from the VCD portal. That's available from the 10.2 release onwards of VCD. All right. Is there any other question?
Yeah, and Ranjit is asking again about the integration plans with Tanzu Kubernetes. Yes, Ranjit, we do have integration plans with Tanzu Kubernetes. We have AVI controller ingress services, which is integration with Kubernetes, but with VMware Tanzu is also coming up. In fact, we have a very exciting webinar planned in the month of February, month after next, exactly on this topic. So please stay tuned. Do you have AVI certification? Is what Sai is asking.
Not sure about that. We used to have aviator certification. I'm not sure right now. Mm.
So there's another about Sai. We're going to get back on RV certification. There's another question on how the traffic gets distributed between multiple pools in RV. In other words, what do you call in RV as it's called I rule in F5? What is the equivalent of that in RV?
Yeah, sure. So multiple things that you require iRule for in F5 can be easily done just by clicking and pointing on AVI. So you don't actually need to write any script or iRule or something like that. Let's take a look at in on the setup right now. So the whatever pool that you have selected, we will automatically load balance on it, but you can control that using things like HTTP policy, request and response policies. For example, are uh, if you want to match some client IP or say some path and want to uh, forward that, so say you want to add a custom values called foo. Anything going for this to this foo address, you can automatically redirect, modify, or content switch to a certain pool, or even select a certain server within the pool. So that way you can manage how you want to route the traffic within the load balancing, basically. And almost 99% of the things that you do can be directly done using this kind of a policy framework. If there is something specific that is not supported, we do also have support for data scripts, which are kind of analogous to iRules, but these are written in Lua language, LUA. Hope that answers your question. So, do you have any more?
Hey, Bhushan, would you mind just opening up the URL that you're sharing there for as far as Avi test drive is concerned? Also,
Yeah,
pull up the workshop page so that people know where to follow up with these workshops. So we offer so on top of webinars, we also offer two types of workshops. One is intro workshop. They're 90-minute long, where you get a chance to actually, instead of watching a live demo, you actually get a chance to get your hands dirty and access our Avi Lab and complete some basic task in the 90 minutes. And we also, after that, you also have a 4-day option, which a few hours a day, where you really get to deep dive in some of the topics that some of you asked about HA, somebody asked you about, the Tanzu integration, Kubernetes story, multi-cloud automation, and all that. So those you can attend the 4-day workshop, which is offered both in America, EMEA, and APJ. So I will definitely visit this page and to sign up for the next one. Bhushan, do you want to show the test drive page?
Yeah, I have it out here. Can you see? The test drive is also there. I already shared it. Yep. All right, yeah, I think if there are no more questions, that's all I had on the presentation side too.
I don't know if we have Serbi's audio back yet, but just to wrap up here, that you will get an email, follow-up email with the slides, as well as the recording of this webinar. With the same link, your coworkers can also watch the on-demand. And we run these webinars pretty often, at least once a month, or sometimes 2 topics a month. So come and check our webinar page, workshops page, and then go try Avi yourself. And the benefits should be really apparent. Okay, all right. Otherwise, thank you everybody for your time. And if any questions that we didn't get back to you, we'll make sure we loop back to you offline as well. All right. Thank you very much. Bye, and have a good day.
Thanks, everyone.